water is a good solvent and it can dissolve many substances in it. Is it right? Hence, water is also known as universal solvent. If the water that consists of what? Both bicarbonates of what? Calcium and magnesium. Such waters are said to be temporary hard water. Cation exchange processes, we can easily exchange the ions which makes the hardness of the water. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called hydrogen. Under that, we have discussed about the introduction to the water and we have discussed about the structure of water in the gas phase as well as in the solid state. And also we have learnt about the important physical and chemical properties of water. Today, let us move on to the next topic of this unit about the hard and soft water and the differences between hard and soft water. And we are going to understand the types of hard water and finally we are going to understand the method of removing the hardness of water. So firstly, I'll go with the hard and the soft water. We know that water is a good solvent and it can dissolve many substances in it. Is it right? Hence, water is also known as universal solvent. And we know that water is a colorless, tasteless and a odorless liquid. And it is also known as universal solvent, and we all know that the water will be moved from different sources, especially from the soil as well as from the rocks. When it is moving, it also carries some of the minerals. So when it is carries some of the mineral, it will be get dissolved in a water. Is it right? Yes. The calcium and the magnesium ion which is dissolved in the water, which are the most two common minerals which will be always present in the water, and that causes a hardness of the water. And remember, the degree of hardness of the water will be become greater as greater only when the concentration of calcium and the magnesium ion in the water content will be get increased. Okay. Then the presence of calcium and the magnesium salts to form a hydrogen carbonate or a chloride or a sulfonate ions in the water, which makes the water to behave as a very hard in such water which is known as hard water. So how does a hard water will be formed? Because we know that the water sources will be different. As it is moving from the different sources, especially from the soil as well as from the rock, when it is moving, it also carries the many minerals. Especially the calcium and the magnesium minerals, if it is found in excess quantity, such water which is known as hard water. Why we call such water to be hard water? Because it forms a hydrogen carbonate as well as with a sulfate as well as with the chloride ions, which behaves the water to become very hard, and such waters are also known as what? Hard water. The soap which are containing sodium stearate, which is readily react with the hard water and forms a precipitate of calcium and magnesium stearate. Here you can see that this is a stearate of soap where it is reacting with the calcium or the magnesium ions. It forms what? It forms a precipitate of the sodium or the magnesium stearate. This sodium or the magnesium stearate, which is also known as what? Scum, which makes the water not to form a lather. Okay. So what is that precipitate we call? We call it as a scum. And if the water which is free from the soluble salts of calcium and the magnesium salts or the magnesium ion, such waters are said to be soft water. So these are the introduction to the hard and soft water. So how does the hard water will not form a lather with the water? Because when a hard water, if you take it and if you dissolve the soap on it, it does not form a lather. Instead of this, it will form a scum. That is mainly because the sodium salts of fatty acids, that is the soap, which form a magnesium or the calcium stearate. Okay, this calcium or the magnesium stearate ion, which will be nothing but a precipitate, which makes the water to behave as a hard, and it does not responsible for formation of lather. Such waters are considered as a hard water. And remember, if I say it is hard water, we have to know about the soft water also. If the water do not contain any soluble salts, it may be magnesium salt or calcium salt, such waters are said to be soft water. Now let us see the differences between hard water as well as with a soft water. We all know that in the hard water, there will be a presence of calcium and magnesium salts. It forms what? Hydrogen carbonate as well as the chloride and sulfate. Whereas in a soft water, we have understood that those water which is free from the soluble salts of calcium and magnesium. And it does not give a lather with the soap, whereas soft water, it always give the lather to the soap. And the hard water form a scum or precipitate with the soap molecule, whereas soft water, it do not involved in formation of scum or a precipitate with the soap molecule. This is how we can easily differentiate the hard water as well as with the soft water. Now let us see the types of the hard water. So there are two types of the hardness will be there. The first one is temporary hardness and second one is a permanent hardness. Okay. So temporary hard water and permanent hard water. Let us see what is temporary hard water. How does it is caused in the hard water? Let us see. The water that contains bicarbonates of calcium and magnesium of both, they are known as temporary hard water. If the water that consists of what? Both bicarbonates of what? Calcium and magnesium. Such waters are said to be temporary hard water. These bicarbonates will be soluble in water and produces the corresponding ion, and these minerals which yield the calcium and magnesium cations and bicarbonate anion. You can see here that is MgHCO3 2. So here you can see that this is a magnesium bicarbonate. So during this processes, when it is dissolved in a water, you can see that it forms a magnesium cation and bicarbonate anion. You can see that similarly with the calcium bicarbonate, when it is dissolved in water, it forms what? Calcium ion as well as with a bicarbonate anion. This shows that this temporary water, which always consists of bicarbonates of calcium and magnesium ion. Such waters are said to be temporary hard water. Next is permanent hardness or permanent hard water. So it is usually caused by the presence of calcium and magnesium sulfate and chloride in water. This is caused due to the calcium and magnesium chloride and sulfate which is there in the water, and permanent hardness of water cannot be removed by boiling. Whereas temporary hardness of water can be we can remove it by boiling that such hard water. Okay. Then the hardness of the water due to the presence of dissolved chlorides and sulfates of calcium and magnesium of both, such waters are known as permanent hard water. You can see here the calcium chloride and magnesium sulfate. So these two are the two minerals which are having chloride and a sulfide ion. Is it right? So you can see that it forms a calcium cation and chloride anion. Similarly, the magnesium forms a magnesium cation and sulfate anion. This shows that when we say it as permanent hard water, remember which always consists of calcium chloride or magnesium sulfate as their ions. That is why which causes a permanent hardness to the water. And remember, we cannot remove the permanent hardness of the water by boiling. Despite the name, the hardness of the water can be easily removed by water softener column. Temporary and permanent hardness of the water can be easily removed by several methods, and the process of converting the hard water into soft water, which is also known as softening of water. Now let us see the differences between the permanent hard water and temporary hard water. So the temporary hardness is mainly due to the presence of calcium and magnesium hydrogen carbonate. We know that the permanent hardness of the water is mainly due to the presence of the calcium and the magnesium ion which is present with the chloride and the sulfate which is there in the water. And temporary hardness of the water can be easily removed by boiling, whereas permanent hardness of the water we cannot easily remove by boiling. So these two are the main differences between temporary hardness of the water and permanent hardness of the water. Now let us discuss few important methods to remove the hardness of the water. First, I'll go with the boiling. Okay. The temporary hard water can be softening by heating. On heating, the calcium bicarbonate is converted into less soluble calcium carbonate, and therefore the most of the calcium ions are get precipitated as calcium carbonate. Similarly, the magnesium bicarbonate is converted into magnesium hydroxide, which is upon due to the hydrolysis of magnesium carbonate, which is formed. The magnesium hydroxide, which is being less soluble than magnesium carbonate, and most of the Mg2+ ions will be get precipitated as magnesium hydroxide. Here you can see that magnesium bicarbonate and calcium bicarbonates are the salts or the minerals which is present in temporary hard water. Is it right? So when it is allow the reactions to taking place, it forms what? Magnesium form a magnesium hydroxide with the formation of carbon dioxide. Similarly, the calcium carbonate will be formed due to the reaction of calcium with the carbonate with the formation of water molecule, and carbon dioxide will be get released out. So this will be done by heating the water. So if you heat the water, or if you boil the water, you know the magnesium bicarbonate and the calcium bicarbonate which is present in such water will be converted into magnesium hydroxide and calcium carbonate. This process of removing the temporary hardness of water by boiling, which is also known as what? Softening of water. So the insoluble precipitate, you know, that can be removed by filtration later, and pure water will be taken out. This is how by simply boiling also we can easily remove the hardness of water. Next is by Clark's method. So this is another method where we follow for the temporary hardness of water to remove it. Okay. So there are two methods we follow to remove the temporary hardness. The first one is by boiling and second one is by Clark's method. So in this method, the temporary hardness of the water is converted into soft water by adding the required quantities of calcium hydroxide. So this method is known as Clark's method. In this method, magnesium ions will be get precipitated as magnesium hydroxide and calcium ions will be get precipitated as calcium carbonate. These two are the bicarbonates of calcium and magnesium, which is allowed to react with calcium hydroxide. What does it form? The calcium which is reacting with the carbonate and forms what? 2 calcium carbonate. Similarly, this calcium reacting with the carbonate and forming calcium carbonate with the formation of water molecules with the calcium bicarbonate. But if it is reacting with the magnesium bicarbonate, it also forms a magnesium hydroxide with the formation of water. Remember, the calcium carbonate and magnesium carbonate are the 2 precipitate which can easily filtrate it out and you can take the pure water. This is another method to obtain the pure water from the temporary hardness of water by adding what? Calcium hydroxide. So, this method which is also known as what? Clark's method. The method for removing the permanent hardness. So, in the permanent hardness of the water, the hardness of the water can easily be removed by using washing soda method. We know that what is a washing soda, which is nothing but a sodium carbonate. Sodium carbonate, which is also known as what? Washing soda. Sodium carbonate, which is also known as what? Washing soda. How does, by using washing soda, how we can remove the permanent hardness of the water? Let us understand now. The washing soda reacting with soluble calcium and magnesium chloride and sulfate in a hard water to form a insoluble carbonate. Here you have a reaction. You can see that this is a magnesium chloride which is allowed to reacting with the washing soda. It forms what? Magnesium carbonate, which is a precipitate with the formation of sodium chloride. We know that again sodium chloride is a salt and we can easily separate it out by doing the filtration. Similarly, when magnesium sulfate is there, when it is reacting with washing soda, it forms what? Magnesium carbonate with the sodium sulfate. Again, these two are the precipitate. Similarly, the calcium chloride and the calcium sulfate, when it is reacting with washing soda, it forms what? Calcium carbonate and sodium chloride with the formation of sodium sulfate. This is how you know this insoluble carbonate as well as the sulfate will be formed, which can be easily get filtrated out to obtain the pure water. This is how the permanent hardness of the water can also be easily removed by using washing soda. Okay, so which is also known as what? Sodium carbonate. Next method is Kalgan processes. The Kalgan is another trade name of a complex salt. It is also known as what? Sodium hexametaphosphate, and it will be written as sodium PO3 6. Sodium hexametaphosphate, which is known as what? Kalgan reagent, and which is a complex salt. It is used for softening of hard water. Kalgan can ionize to give a complex anion. Here you can see that this is our Kalgan, and which is upon reactions which is given as what? Sodium ion, or with the formation of complex anions will be formed. You can see that NH4P6O18 2- is a complex anion will be formed from the Kalgan. Okay. So, the addition of Kalgan to the hard water which causes the calcium and the magnesium ions to the hard water to displaces with the sodium ions to form a anions of Kalgan. Here you can see that I have taken out the hard water which consists of what? Calcium, which is allowed to reacting with complex anion which is formed from the Kalgan, which forms what? This sodium which also replaces with the calcium and forms a sodium calcium Kalgan will be formed. So, this will be goes to the solution with the formation of sodium ion. This is how the permanent hardness of the water can be easily removed by using a complex salt known as Kalgan, which is nothing but a sodium hexametaphosphate. phosphate. This results in a removal of calcium and magnesium ions from the hard water in the form of complex with a calgon, as I have explained here. Okay, this water will be softened and sodium ions will be released into the water. This is how, by using the complex salt known as sodium hexametaphosphate. Next is ion exchange method. In this method, we are using zeolite, or this method which is also known as permutate method or permutate process. Let us see, by using ion exchange process, how do we remove the permanent hardness of the water? Let us understand now. The ion exchange is extensively in a small water system and individual home. In ion exchange resin, which is made up of sodium and aluminium silicate. So, in ion exchange resin, you can see that the resin itself will be made up of what? Sodium aluminium silicate. Is it right? Resin will be made up of sodium aluminium silicate will be there. This is known as what? Zeolite. Sodium aluminium silicate, which is also known as what? Zeolite. So, it will be exchanges one ion from the water which is being treated with the another ion is in the resin. The sodium is one of the component of the softening salt with the chlorine or being with the other. The zeolite is a ion exchanges sodium with the calcium and the magnesium, and this chemical reaction shows that the exchange processes. Here the Z represents the zeolite, which is the exchange material. You can see here the calcium bicarbonate and magnesium bicarbonate which are present in hard water when it is reacting with sodium zeolite. What is the Z stands here? This Z stands for aluminium silicate. Aluminium silicate, when it is reacting with hard water, it forms what? Calcium zeolite will be formed. Similarly, magnesium zeolite will be formed, and you can see that remaining this sodium combines with this bicarbonate and forms a sodium bicarbonate, which forms what? Sodium bicarbonate. This is how the permanent hardness of the water, which is caused by calcium and a magnesium ion, their ions will be easily get exchanged in an ion exchange resin by using what? Zeolite. Hence this process, which is known as permutate processes or zeolite, or which is also known as ion exchange processes. Here I have also have a reaction with calcium chloride and calcium sulfate. The calcium sulfate reacting with sodium zeolite, it forms what? Calcium zeolite with the sodium sulfate precipitate. Similarly, the calcium chloride reacting with sodium zeolite, it forms a calcium zeolite with the formation of what? Sodium chloride. Again, it is a solid, we can precipitate it out. Similarly, if you see that in the permanent hardness of the water, which causes due to the calcium and the magnesium ions, which is formed with the chloride and sulfate. So that is why I have written both the reaction. So magnesium chloride react with the sodium zeolite, it forms what? Magnesium zeolite with the formation of magnesium sulfate. Similarly, the magnesium chloride reacting with sodium zeolite, it forms magnesium zeolite with the formation of sodium chloride. Here I have shown this picture to understand how does the ion exchange method will be done for removing the permanent hardness of water. You can see that this is an entire chamber where you are going to put the water, that is the hard water, and you can see that these are the permutate process which is taking place where the exchange of the ions will be taking place. Is it right? And you can see that this is a ion exchange resin where the ions which is present in the hard water which is get exchanged with the zeolite and forming what? Soft water. And whatever the salts which is formed, it will be leaves out. So this is how when you pour the hard water, it will exchange its ions with the resin and give rise to the soft water. Hence this is another important process where you are easily can removing the hardness of the water by using ion exchange resin. Next is synthetic resin, and this process, which is also known as what? Cation exchange resin method. Okay, let's see how by using synthetic resin also we can remove the permanent hardness of water. The cation exchange resin consists of large organic molecules with SO3H group which are water insoluble. The ion exchange resin, which consists of what? RSO3H group, which is a cationic exchange resin, which is changed to the RNA by treating with sodium chloride, and the resin exchanges a sodium ion and a calcium and magnesium ion present in hard water and makes the water to behave like soft water. You can see here our resin will be made up of what? RSO3H, which will be get converted into what? RNA. So when it is converted into RNA, which is allowed to reacting with the salts which is present in hard water, it may be calcium ions or magnesium ions. What does it forms? R combines with the salts and forms a R2M with the formation of sodium. You can see with the example by taking the magnesium ion reacting with the R and forms a RMG and with the formation of sodium ion. This shows that by using cation exchange resin, we can remove the hardness of the water which is caused by calcium and magnesium ion. The resin can be regenerated by adding aqueous sodium chloride solution. The pure deionized water will be free from all soluble mineral salts which is obtained by passing successfully through the cation exchange and ion exchange resin. Here you can see that the RH, which is nothing but a cation exchange, which is allowed to reacting with the hard water. It forms what? RMG with the formation of 2H plus ion. So this cation exchange process, which is having the H plus ion, exchanges with the sodium, calcium and magnesium and other cations which are found in water. This process results in proton release and makes the water to be acidic. And in ion-ion exchange process, these many reactions will be taking place. You can see that this is a RNH2 that is reacting with the water molecule, that may be hard water. You know, it will accept one of the proton and get converted into ammonia with the formation of OH minus ion. Similarly, this RNH3OH minus ion reacting with the halogen, it may be chloro or bicarbonate or with a sulfate and forms what? RNH3X minus and O minus. So the O minus exchanges of anions with the X minus present in water with the liberation of OH minus ion neutralizes the H plus ions from the water. You can see that the OH minus ions, again if it is passed with the cation exchange resin, it neutralizes the water to become water to be neutral from the acidic nature. So the exhausted cations and anions will be exchanged the resin beds for regenerated by treatment with dilute acid and alkali solution respectively. This is how by using cation exchange processes we can easily exchange the ions which makes the hardness of the water. Okay. So in the next session we are going to study more about the hydrogen peroxide, their structure, physical property and their chemical property and their nature. Okay. By this, I like to say that what are all the things which I covered in this session about the hard water and their peptides and their how to remove the hardness of the water. It is very important for the examination point of view. Have a look on it. Wherever you are not understanding, please pause the video and write down the reaction, because it is very important to score 3 marks from this simplest unit. So hope you all understood. We'll meet you with the next session. Till that, take care. Thank you.